Hi and welcome. My name is Raphael Taubinger and this video is an overview of IAR Embedded Workbench for RISC-V version 2.10. The latest IAR Embedded Workbench for RISC-V version 2.10 has just been released and brings many new features and improvements. On the compiler, we added the RISC-V standard extension Bit-manip RVB. So as you might know, a hardware extension gives the possibility to use application-specific instruction hardware to replace blocks of codes in the original software to increase execution speed and reduce code size. So this is of course very powerful. 4 types of actions can be implemented in this case. So it's count, extract, insert or swap. So it's a huge impact on performance when it comes to cryptographic hash algorithms, data compression or even signal processing. So additionally, we also added the Andes V5 performance extension. So that's of course used also to accelerate and improve size. And finally, as always, there is lots of improvements in the optimization. On the debugging side, we can now also on the live watch. So for devices supporting direct bus access, we can now have the live update of variables, so you as a developer can add them to the watch window. And on the debug side, there are also some reset mode handlings that have been improved. As usual, we added many new devices, so the full list can be found at IAR.com in the release notes or just in the description of this video. In the IDE, we also added improved code completion, so there is now a wider scope for assisted situations. For example, when adding include files, there is more information shown with suggestions, for example, on function parameters and types, and we also have a fuzzy matching aids if you are maybe writing or having a syntax error. And finally, there is also the option to customize color in the syntax highlighting. When it comes to builds, the IAR build also got some enhancements, so we are able to generate Ninja build files and also JSON description files. This also reflects in faster building times. So let's have a look on the latest embedded workbench for RISC-V. I will mainly open a very simple example here, but the IAR Embedded Workbench for RISC-V comes with many examples out of the box, starting from Andes, Cloudbeer, GigaDevice, Microchip, Nuclei, Sci-Fi, and Syntacore. I'm going to use one of our simple Product Explorer examples, and it's also included here. So mainly the first step is to just copy this example project to your local disk. And what I'm going to show you here first, as I mentioned before, we support mainly the cores from different vendors here that are being displayed on the list right now. And if you have the extensions, first you start either by the base extensions here. You can go also to the embedded extension. The standard extensions like M, A, C or the Bit-manip extensions, if they are supported, you can enable them separately. So it's very easy and straightforward to work from here. We also include here in the IAR Embedded Workbench CStat. That's mainly to help you with code quality, find bugs statically in advance. So really straightforward, integrated here from the standard checks like a collection of good programming practices, CertiC, MiserC, all available here in just a few clicks. On the debugger side, we fully support here the IAR iJet Pro, but also the simulator that can be very useful, and that's mainly. So if I just go here to my project and go to one of the files here, I can show some of the code completion features. I mean, for example, if you start typing here, it starts to suggest you, of course, many options. As you can see, we have the chance to just navigate here, very easy and straightforward. If you, for example, also have a function that you want to use, I can mainly go here to the source code line 33, and if I start right tapping here print, you can see that all the options pop up. If there is any fuzzy way, for example, if you have a typo or write it in the wrong way, it will just still suggest, because most of what you have written might of course fit with print F here. So very straightforward, easy to use, the completion that's available. You can always customize the shortcuts, and even if you want to disable the feature, you can do that and just invoke it on demand. So if we look here on the predefined shortcuts that we have connected to code completion and so on, we have here different options. If I just scroll down here, we have different complete word, complete code, parameter hint, and so on. So if you look here, it's mainly Control-Alt space, Control space. So this can be customized the way you want. The syntax highlighting can also, of course, be customized. So that's all really straightforward. So you can work here with colors and so on. You just add extra syntax coloring here for you. Good. Once I built this project here, we will see that it just runs fine. You can always see the source code size on the map file. It's a small file that I'm using here. But for example, if I just move here and choose higher optimization levels, let's say high size, we might move here to better optimization. So we have here the initial value, it's 1356. If I just rebuild this, we reduce this to 1252. So it's kind of a significant code reduction that you have just by manipulating the compiler. If I just connect to a debug session here, you will see that all the capabilities that are available can be invoked here under the view menu. So I will just show you what's available. So we can see here from watch or live watch, memory. So if I open this window here, you can navigate to any function or just address as you want. You have also the possibility to see registers, for example. You can even go and see different groups that might be available, like PWM, SPI, and so on. So you can have insight on the microcontroller, for example, that you might be using. So I can leave this application running for a while, but we have full control here from stepping in, stepping over. So this is all, of course, available here. And I also have the timeline with interrupts or even data log enabled here. So if I just, for example, select the counter I have here and add it to the log breakpoint here, so it will appear here on the timeline too. And if I leave this application running for a while here, we will see that something is happening. So by looking a bit closer here, you can see that it will tell us that the timer interrupt has been triggered a few times. And if we play a bit around here with the zoom, we can see that counter has been displayed here on the timeline too. And if you need to do some time measurements, that's also very handy. You can mainly select the time between the interrupts, and it will tell you that it's exactly 2000 cycles, or T2 minus T1, it's 40 microseconds. So that it's really powerful when you're measuring the behavior of your application, how the code is behaving. But of course, you have more capabilities available here. For example, if you enable the function profiler, you can even see where you're spending most of your time in the application. So this gives you very good information and a reference. So we can see that most of the time we are spending in main, it's just a loop inside main, but there are some other functions that are listed here in the list. So very powerful, very useful. So this is the IAR Embedded Workbench. So, and finally, thank you for your attention. If you would like to get more information, please access IAR.com/RISC-V or just reach out to FAE@IAR.com. Hope you enjoyed this video.